Next topic under our discussion is shapes of orbitals. If you go for shapes of orbitals, as you know that when you go for types of orbitals, we have s orbital, p orbital, d orbital and f orbital. So if you go for s orbital, and s orbital has spherical shape. It has spherical shape. Spherical shape with the uniform distribution of electron cloud. Uniform distribution of electron cloud, and the shape of that orbital is given by s orbital. Because it is spherical in shape, you find the electron density or the electron cloud is distributed uniformly. Electron cloud is uniform, and you find that the electron cloud distribution is uniform. That's what I'm saying. X-axis, in the x-axis you find the same volume of the electron cloud you notice in the x-axis, same volume of the electron cloud you notice in y-axis, and the same volume of the electron cloud density you notice even in the z-axis. So therefore it is very clearly visible that it is because of the uniform plane of symmetry. We cannot differentiate the s orbital as sx axis or sy axis or sz axis, because the electron density is distributed uniformly throughout the volume of the orbital, spherical shape orbital. So that's why this is called uniform distribution of electron density. That is why we can say that it is spherical in shape. Then next go for p orbital. Actually a p sublevel has 3 p orbitals. One is px, py and pz. When you go for px, py and pz, what do you mean by this is, that is, for example, I am taking here, that is if I am noticing this is the shape of px orbital, this is the shape of px orbital, x-axis, this is y-axis and this is z-axis, this is px orbital. You are finding that in the px orbital, of course the shape of p orbital is dumbbell shape. Dumbbell actually, so we call it as dumbbell shape. If you take dumbbell shape, this dumbbell is made up of 2 lobes. These lobes are directing themselves in a particular axis. If you carefully observe the px orbital, you are finding that electron density alignment is taking place only in the x-axis, but the electron density is not taking place. There is no electron density available in the y-axis and z-axis in the case of px orbital. So the plane in which there is no electron density, the plane in a given orbital where there is no electron density is called nodal plane. Plane in an orbital with the 0 electron density is called nodal plane. So we are finding nodal planes in this px orbital. We are finding nodal planes in z-axis, we are finding a nodal plane, and in y-axis also we are finding a nodal plane, because here there is no electron density and here also there is no electron density. In y-axis there is no electron density, in z-axis also there is no electron density, but however the electron density is there in the x-axis. It is along with the 2 lobes. The 2 lobes joins together to form a dumbbell, and this dumbbell is oriented along the x-axis, and this is the shape of the px orbital. Go for py orbital. If you go for py orbital, again if you take here, that is this is py orbital. You can see the electron density in y-axis, y-axis, x-axis, and this is z-axis. This is py orbital. What you are noticing here is the electron density is aligning itself. The two lobes are aligning itself in the y-axis. So you are finding the electron density only in the y-axis, but you are not finding electron density in the x-axis as well as z-axis. So nodal planes are obtained in the x-axis and z-axis in the case of py orbital, and nodal planes are obtained in the case of y-axis and z-axis in the case of px orbital. Likewise, if you go for, that is, pz orbital, if you go for pz orbital, if you go for pz orbital, this is x-axis and this is y-axis and this is z-axis. Z-axis, this is pz orbital, this is pz orbital, this is z-axis, this is x-axis and this is y-axis. This is pz orbital. You are finding that the electron density is in the z-axis, and electron density is absent in the case of x-axis as well as y-axis. So therefore you are finding the nodal plane in x-axis and y-axis in the case of pz orbital. You are finding the nodal plane in z-axis and x-axis in the case of py orbital, and you are finding the nodal plane in z-axis and y-axis in the case of px orbital. So therefore these are the three different dumbbell shaped structures or shapes of the p orbital. Then next we will go for, that is, d sublevel. D sublevel is having 5 orbitals altogether: dxy, dyz, dzx, and dx square minus y square, and dz square. The shape of the orbital is double dumbbell. The shape of the orbital is double dumbbell. Here the shape of the orbital is dumbbell, p orbital. Here the shape of the orbital is spherical. So I am going to give you a few diagrams here for all these orbitals. Actually, so here what we are noticing here is, in particularly in the case of the d orbitals, before going to the d orbitals, we know very well that every atom is made up of a main energy level. That main energy level is made up of the sublevel. When you say sublevel, here we are speaking about the d sublevel. The d sublevel is having 5 orbitals, suborbitals. That suborbitals we are calling it as dxy, dyz, dzx, dx square minus y square, and dz square. And here the shape of the d orbital is given by double dumbbell shape, which you can see. What do you mean by double dumbbell here? The double dumbbell gives us the impression that if you take 4 lobes, 2 lobes will make one dumbbell, so another 2 lobes will give you another dumbbell. So you are finding that 4 lobes is giving a double dumbbell shape for a given orbital. So because you are finding that these d orbitals, because they are having this d sublevel, because they are having 5 orbitals. In the case of dxy, what you are noticing is, you can see that the dxy orbital is having 3 axes, one x-axis, one y-axis, and one z-axis. You can see the electron density in the first dumbbell is along with the x-axis. You can see the electron density of the x-axis is across. That means the lobes are across the x-axis and the electron density is also across. And for y-axis also, you can see the electron density is across the y-axis of the 2 lobes. Okay, that is, you can see the 2 lobes here. And where the electron density is not available, the electron density is not possible in the case of the z-axis. That is, because it's a double dumbbell, we can say that the electron density is 0 with respect to z and y. Electron density is 0, and the electron density is also 0 with respect to z and x. So when the electron density is 0 in yz and zx, that means the nodal plane in the case of dxy orbital is available in the plane of zx and zy. But however, the electron density in the dxy orbital is across the x-axis and across the y-axis. go for the same understanding in the case of dyz orbital also. Again, dyz orbital is double dumbbell. We can see that the electron density is across the y-axis and across the z-axis. From the diagram it is very clear. And where the electron density is not available, the electron density is not available with the zx plane and yz plane. You find that there is no electron density, so the nodal plane is obtained in zx and the xy plane of dyz orbital. If you go for dzx, you can see that the electron density is across the z-axis and across the x-axis from the diagram, and the electron density is completely not available in the case of y-axis. If it is not available in the case of y-axis, that means the nodal planes where the electron density is 0 you are able to observe in xy and yz plane. If you go for dx square minus y square, here the electron density is along with the x-axis and along with the y-axis. Here if you take, that is the axis, if you take the axis here, this is x-axis and this is y-axis and this is z-axis, this is zx. Okay, so if you come here dx square minus y square, here this is x-axis and this is y-axis and this is z-axis. So electron density is very rich in the case of the x-axis and electron density is very rich in the case of y-axis. That's why here the orbital is dx square minus y square, and here this is a collar like thing. This is a collar dz square and it has two lobes. The two lobes are, the electron density is across the z-axis. The two lobes in the dz square orbital are separated by collar, and it's a single lobe, single double lobe, which gives the dumbbell shape structure, that is dz square. Only dz square is having the dumbbell shape like structure, but remaining all four orbitals of the d orbital, they are double dumbbell in their shape, and this gives us the complete information about the shapes of orbitals.